Quality vibration data that managers can rely upon when making critical machinery maintenance decisions starts with proper accelerometer installation techniques. Hi, my name is Mike Scott, Industrial Monitoring Division of PCB Piezotronics. In this video, we're going to take you step by step through the vibration transducer installation process from mounting to cabling. We'll cover accelerometer mounting, including using a spot face tool to prepare the machinery surface, cable selection and connection to the transducer, and wiring to a switch or termination box with proper grounding techniques. The most common indication of bad data when making vibration measurements is an FFT that looks like a ski slope where all of the vibration amplitude is concentrated in the lowest frequency bins on the plot. Following the techniques presented in this video will reduce, if not eliminate, this phenomena from occurring during your data collection. A smooth machine surface free of paint is essential for accurate measurement of vibration. First, we use a spot face tool to shave away the paint and a little of the top layer of metal on the machine, creating a smooth surface and the beginning of a pilot hole. Be sure to clear away the chips and debris. The depth of the pilot hole should be at least 1/4 inch, or 6 to 7 millimeters. Ideally, our spot face diameter is at least 1.1 times the diameter of the accelerometer's mounting surface. Tap with the appropriate thread, in this case 1/4-28. When installing the mounting stud into the bottom of the accelerometer, be sure the brass tip goes into the bottom of the sensor. The brass tip is designed to collapse in situations where the accelerometer is over-torqued. This prevents damage to the accelerometer. Next, after some silicone grease is applied to the bottom of the accelerometer, it is tightened by hand into the newly tapped mounting hole and torqued to 2 to 5 foot-pounds or 3 to 7 Newton meters. Silicone grease allows for good mechanical coupling and superior accuracy when reviewing high-frequency vibration data. When mounting via adhesive mounting pad, the spot face process is the same as when stud mounting. The paint and top layer of machine surface is shaved away with the spot face tool. In this case, the pilot hole is not used. The surface should be clean and free of debris. Putting a stud through the adhesive mounting pad before applying adhesive prevents the adhesive from flowing into the threads in the center of the pad. Later, we'll use this same stud to mount the accelerometer with the brass tip installed in the accelerometer side. This side of the pad will mount to the machine. The grooves allow for more surface area and higher strength bonding. The flat side will couple with the accelerometer. Epoxy is applied and then the pad is pressed into the spot-faced surface. A heat gun can be used to speed up the curing time. Finally, the stud is removed from the center of the adhesive mounting pad, installed in the accelerometer, brass tip in first, and then the accelerometer is stud mounted. 2 to 5 foot-pounds of torque or 3 to 7 Newton meters of torque are required. The model BR connector is one of our most popular. This 2-socket mill connector with keyway features a collar made out of santoprene and a molded composite back shell. It's cost-effective, seals nicely, and santoprene has a good spectrum of chemical compatibility. But it's not a metallic connector and therefore won't hold up as well against physical damage. The Model AE connector is one of our highest quality 2-socket mill options. It's made out of silicone, which has excellent compatibility in many chemicals. This connector has an ingress protection rating of 67 and works in high temperature applications to 325 degrees Fahrenheit, 163 degrees Celsius. We listed the push-on connection type as a con just because it's different. Technicians who have not used this connection type before might be concerned it's not seated properly, but they will be pleasantly surprised at the sealing and how strong the connector holds to the accelerometer. The Model BP is your typical aluminum 2-socket mill with keyway. Its strength is resistance to physical damage, such as from metal shavings. This connector is also ideal for high-temperature environments to 325 degrees Fahrenheit, 163 degrees Celsius. Polyurethane jacketed cables, such as our cable type 508, are great for sealing out moisture. They are flexible and easy to work with. They have a braided shield, so installers must comb out the braid to create a drain wire. We will cover this in a moment. It's best for you and your applications engineer to check chemical compatibility if there are any concerns about chemical exposure. Teflon jacketed cables, such as our cable type 053, have excellent compatibility in the overall spectrum of potential chemicals. They also slide easily through cable trays and have a foil shield with drain wire for proper grounding. Teflon can survive to 392 degrees Fahrenheit, 200 degrees Celsius. Therefore, in high-temp applications, we recommend it with a high-temp connector like the aforementioned AE or BP models. One drawback is this cable is stiffer with a larger bending radius. It's a little bit more difficult to manipulate around tight turns. The aforementioned molded composite connector is our most popular model. It features the red O-ring seal you see here, which seals out moisture. To install, line up the keyways, push down until seated, and tighten the collar. Again, our metal connectors are more resistant to physical damage than molded composite and can be supplied with clamp-style strain relief on the back shell. To install, line up the keyways and push down until seated, then tighten the collar. Finally, the environmental boot style connector installation is a little different because it pushes on and holds via suction rather than using the threads on the accelerometer. This is an IP67 rated connector. Users are frequently surprised at how strong it holds. The accelerometer is not easily pulled from this connector. Let's review how to create flying leads from a blunt cut cable. In this case, we're using our polyurethane jacketed cable. First, the cable jacket is stripped away. Then the braided shield is pushed back, making it easier to cut away without damaging the connectors. With the shield removed, we can see the positive red wire, which is the signal wire, the blue wire is ground, and the shield drain wire, which also runs the full length of the cable. Next, the sheath over the signal and ground leads is stripped away. An optional step is to tin the leads. This makes them easier to install in the termination box. All of our cables are available to be ordered with stripped, tinned, and labeled leads. As part of that service, IMI will also install heat shrink at the point where the conductors exit the cable jacket and shield for added strain relief and protection. Every IMI sensor's termination box has a grounding lug at the bottom left-hand corner. The grounding lug is wired to shield on the back plane of each terminal strip. Therefore, all of the accelerometer shields are connected to the grounding lug, which should be connected to earth ground during the installation. This prevents noise from affecting the vibration measurement, which can lead to artificially high vibration levels and ski slope in the FFT. The nut on the cord grip is removed and the cable for each accelerometer is fed through the bottom. For easier connection, the terminal strips on the termination box pop out. The red signal wire is connected to the positive terminal. The blue ground wire is connected to negative, and the drain wire for the shield is connected to the shield termination. Tighten the terminals with a flathead screwdriver and reconnect to the board. Once installed, be sure to tighten the nut on the back side of the cord grip. The nut acts as a strain relief for the cable and tightens a rubber O-ring around the jacket. We repeat the process for channel 2. Again, it's very important to connect the shield's drain wire. All of the drain wires are routed to the grounding lug at the bottom left of the box, which should itself be connected to earth ground during the installation. Snap the terminal strip back into place for channel 2. And retighten the nut on the back side of the cord grip. Finally, we're using the red Teflon jacketed cable on channel 3. The only difference here is the black conductor is accelerometer ground, red is still signal, and we will still connect the drain wire from the foil shield. Thanks for watching. We hope the techniques presented in this video will improve your vibration measurements. There are dozens of videos, white papers, technical notes, and even lists of frequently asked questions in our learning portal. Please visit pcb.com/learn for more educational content.